Welcome to Brain Vision.
We begin this question by calculating the acceleration of the fireman. We can do that by using Torricelli's equation. It tells us that the final velocity squared is equal to the initial velocity squared plus 2 times his acceleration times his displacement. Also, let me choose that everything that is pointing upwards is positive. Then, his final velocity is 1.4 meters per second. His initial velocity is 0 because he starts from rest. Then we have plus 2 times the acceleration times the displacement. And the displacement was 4 meters, but 4 meters downwards. Therefore, he started at some height and finishes at a smaller height, meaning that in my reference frame, the displacement is negative and equals to minus 4 meters. Then we solve this equation for a as follows. 1.4 squared is equals to minus 8 times a, so that his acceleration is equals to 1.4 squared divided by 8 with a minus sign in front of it. And this is minus 0.245 meters per second squared. Now that we know his acceleration, we can use Newton's second law to calculate what is the frictional force. Newton's second law tells us that the net force is equal to the mass times the acceleration of the fireman. Then, the net force is composed by two forces. The frictional force that points upwards, so it's positive, minus the weight force that points downwards, and therefore it's negative. And this is equal to the mass, 86 kilograms, times the acceleration of minus 0.245 meters per second squared. Then, the frictional force is equal to 86 times minus 0.245 plus his weight. Remember that the weight is given by the mass times the acceleration of gravity, which is approximately 9.8 meters per second squared near the surface of the Earth. So, plus 86 times 9.8. Then, the frictional force is approximately 820 newtons.